Mining and mineral development is as old as civilization. There is a recorded evidences of mining since 5000 BC, and evidences from the pre-Harappan civilization shows that mining was carried out in the period 4000 to 2000 BC. Carbon dating has established a lead zinc mining in Rajapur Dariba of Rajasthan during the period 1260 to 60 BC. We have thus a continuous history of development of mining and mineral productions for well over a 60 millennium. Mineral resources are natural resources. They are finite and non-renewable. They constitute the basic building blocks for civilized life and economic growth. They provide inputs and raw materials for agriculture, industry and construction activities, and are of major resources for development. The occurrence of minerals, which you can see in case of these minerals, is uneven. Then mining is truly global industry and especially a widespread activity. As known mineral resources is finite, unless intensive exploration efforts to discover more subsurface finds succeed and life indices are extended, there is a need for effective conservation of minerals. As mining has adverse environmental impacts, there is need to develop a clean technologies that support a sustainable mining and development. We therefore need to judicially conserve mineral wealth unless their abundant availability is assured. In the event of that, mineral endowment on land is unable to meet the demand, especially in the case of some minerals whose life indices are around 20 to 50 years. So, we may move towards a seabed mining. India is reasonably well endowed with mineral resources. Mining in India can confer a benefits of opening up of a backward areas, dispersal of industry, generation of employment, boosting of exports, and provide the much needed multiplier effects on the economy. The mineral deposits or ore deposits that are cropped out on the surface or near the surface can be mined by open pit or open cast mining methods, whereas the deep seated mineral deposits can be worked by underground mining methods. Veins and beds that are inclined at high angles cannot be mined to special advantage by the open pit method unless they are very thick. Extensive flat deposits buried under a moderately thick cover or directly exposed are the best suited for open cast mining, and they are more advantageous by doing a open cast mining methods. The varying thickness of ore burden and the structure determines the feasibility of open cast mining. A deposit comprising a small amount of open pit ore and a large amount of deep ore would be mined by underground mining methods. The boundary line between the open pit and the underground mining for a given deposit is established by the differential between a open pit and underground mining with the cost of surface excavation. Open pit planning procedure. So, the open pit can be planned using following general procedures. One is long term planning. This involves exploiting a deposit profitably to obtain extraction of the whole of the reserves or up to the cutoff point. Mid-term planning, the programs which are in greater detail and are related to annual production. Short-term planning, this includes a detailed control of day-to-day production. Planning informations. Planning informations includes which are essential for execution of open cast mining are as follows. One of the important information we have to see in case of maps. So, we have to prepare the maps according to our requirement. One is a topographical plans with surface contours at close intervals. Then borehole plans showing altitudes, mineral thickness, thickness of the deposits and overburden ratio and mineral grade. Then hydrological plans showing actual levels of free groundwater table, contour of the base of the deposits and base of the overburden, plans of available reserves, mining plans showing blocks to be worked and match over. Now, let us come into the second important informations we will get in the form of sections. One is geological section, bench levels, mineral grade, exposed reserves, groundwater tables, etc. And finally, with the help of the sections and with the help of the maps, we have to prepare the data, that is in the form of volumetric control, machine output, transport capacity, meteorological record, management statistics. So, some of the factors which affects the mine layout. The important is that the shape of a mineral deposit fundamentally determines the shape of the mine, and the physical characteristics of the mineral determines the choice of the machines. So, the major factors affecting the layout are as follows. One is the shape and depth of the deposits. This is of particular importance since the selection of a transport system is restricted by the distance and the vertical height through which a overburden and mineral must be moved. The properties of the mineral and of the overburden. Then slope angle limitations of both working faces and side walls and spoil heaps. Then degree of hardness and abrasiveness which influence the selection of the excavating and transport equipment. Variations in grade of mineral deposits. Then competence of the various rocks to support the equipment. The geometry of the excavating machinery, particularly a digging height, depth, dumping height and reach. The drainage requirements, particularly the maintenance of drainage slopes to sumps in such a way as to safeguard the working faces, benches, spoil heaps and access roads at all times during the mine from the influence of groundwater. Saturated slopes are much more likely to collapse than well drained. The nature of the material, the topography and the general conditions, the quantities to be handled over available capital, engineering and manpower determines the methods of excavation and selection of mechanical appliances or machines. Small scale operations may make use of manual methods like picks, shovels, cart, wheelbarrows, mine cars and track. Materials handled in open cast operations ranges from alluvial, odd pans, clays and shales up to hard rocks. Open cast mining methods by manual method is adopted where large investment is not warranted. Mechanization is likely to prove inefficient due to their large size of pits and their location. Mineralization is erratic and selective mining and sorting is called for. Large scale work is possible with cheap labor. Open cast mining with loading by machineries. The minerals worked in a big open cast mine or a big open pit mine are mainly example a coal, iron ores, low grade copper ores, manganese ores, etc. Other minerals may be worked or surface outcrops, but the size of the outcrops usually implies a smaller operation with the smaller sizes of machinery, although techniques are same. The most important types of machineries used in the open cast mining are drag lines, power shovels, scrappers, land dredges and overburden bridges. Drag lines. A drag line consists of a prime mover, either they can run with electric motor or a diesel or a petrol engine housed in a body. The engine activates the drums as well as the ropes and are attached to the either end of a long heavy scraper or a bucket. The operator sitting in the cabin moves the pulley so as to make the scraper or a bucket to swing a to and fro from pulley while the rope is held tight. When the swing of the scraper has attained a large amplitude, the ropes are suddenly released. The scraper is flung far away and lands on the ground with a great impact, digging deep. Now, the rope is tightened and the scraper is drawn along the ground, gathering the debris. The operation is repeated so that the desired excavation is made with the help of a drag lines. So, the drag lines has a longer reach than the power shovel, but it is not so convenient for loading into cars and wagons, as it cannot lift up the broken rocks and excavated materials. It is essential that the dragline should have a firm base to prevent it sliding into the pit or sinking into the ground. The second one is the power shovels. The power shovels or mechanical shovel comprises a prime mover which actuates all the movements. It has a dipper arm which is attached to the shovel and a boom. The dipper arm can be moved forward or backward. It can also be moved up or down along the boom, so as to increase or decrease the distance or depth of operations. The machine turns on the turntable. The operation of the shovel placed at a convenient place close to the work spot. The rope is kept loose. The dipper arm moves forward into the debris. The boom is lifted and so also the dipper. The rope is tightened by the drum and the debris is collected by the shovel and loaded into the trucks or dumpers. The shovel is provided with strong steel teeth at the front for digging. It has a hinged plate which opens downwards and facilitates emptying. Thus, the debris fall into the trucks or dumpers with considerable force. Power shovel is more positive in action than the drag lines. By the action of the dipper and boom, the shovel can be made to dig into the broken rocks and lift the same to a considerable height so as to facilitate loading. It can operate on fairly odd materials, example consolidated clays, boulders, sandstones, etc. Thus, the power shovel is often employed for stripping overburden before opening up of quarries. This is used in the lignite mines of Victoria, Australia, and also at Neyveli, Tamil Nadu. Then coming to the third equipment or the machinery, we call them, it is called as scrappers. Scrappers are also used for surface mining. Scrapper comprises essentially a U-shaped steel plate. When dragged along the ground, collects the broken material to a desired spot. Chains are attached to the two limbs of the plate as well as to the back. Wire ropes are attached to the chains and passed over pulley, so that by adjusting their lengths through pulleys, the scrappers can be made to move back and forth. Scrappers are used essentially for collecting loose material and not for excavation. Scrappers are also employed in underground mining in slopes for pushing ore into the ore passes where the dips are low. Coming to land dredges, these are similar in operations to pontoon dredges employed in alluvial mining. The dredge is mounted on a caterpillar and is stationed at the edge of a quarry bench, so that the buckets touch the face. As the chain of buckets move upward, the material from the quarry face is excavated and carried along. The material is dropped from the bucket into a revolving screen or a trommel and then into a conveyor belt for loading into wagons for transport by rail. This type of dredge was used in the lignite mines of Neyveli in Tamil Nadu and also in the lignite mines of Australia and Germany. overburden bridges. In some of the larger open cast working like coal mines, where large amounts of overburden stripping is necessary, the equipment known as overburden bridges are employed, and it comprises a gigantic T-shaped cantilever arrangement which moves back and forth on rails. The main purpose of the bridge, is the name implies, is to transport ore across the mine or pit. It is advantageous as it forms a shortcut for backfilling. The vehicles used most for the transportation of the mineral and barren rock in modern mechanized open pits are large capacity dump cars, hauled by electric or steam locomotives, self-charging trucks and belt conveyors. Large capacity dump cars are mounted on two double axle wheel bogies and used in big open pits. For small scale open pit work, the narrow gauge mine cars of the rocker types are used. Motor trucks employed for open cut work should be adapted for loading and power shovels and provided with automatic dumping devices. The body of the truck is made strong to withstand the impact of big rocks falling from a considerable height. For automatic discharge, there are dump body trucks. Belt conveyors are widely used in open cast mines, and in some other instances for the transportation of coal, the loading of the material into the conveyor and its uniform delivery is ensured by a travelling hooper with a feeder set up over the conveyor belt. The problem of locating and arranging waste dumps and organizing and mechanizing a spoil disposal in open cast work is extensively important. The cost of overburden transportations may then constitute a substantial part of total mining expenditures. Waste dumps are classified into two categories. One is internal or inside dumps and another is external or outside dumps. Internal or inside dumps. The inside dumps are those where the spoil is disposed of in the pit itself. Transportation of overburden to inside waste dumps is simple and cheap. Inside waste dumps can also be built up with the aid of belt conveyors. A further step in the direction of rational spoil disposal inside the pits has been made with the applications of overburden bridges. The inside waste dumps or spoil banks require a definite conditions, and it is practiced only in certain open pits. In majority of the open pits, arrangements are made so dump the waste outside the pits. Second one is outside waste dumps. The outside waste dumps should be dumped in lowlands or on valley slopes. In some cases, flat land is allocated for waste dumps. In order to obtain the initial specified height of the dump, in the case an inclined fill is built up by a power shovels. The dumps may be made a fan shape. In the first instance, the spoil loaded and the initial fill from which the dumps are built up on both sides. First in fan like fashion until it is possible to link the ends of the track lines and form a loop. Turning point A is the point from which the tracks radiate. The big open pit prefer the loop scheme. The lumps may also be double benched, that means the dumps in built in two benches with partly a loop like and partly a switch back. The principal means of used for transporting the overburden to the outside waste dumps, the large open pits or trains or large capacity dump cars drawn by heavy electric or steam locomotives. Then ancillary equipments. A list of ancillary equipments will include the items such as the following: bulldozers, cable cars for laying a reclaiming electric high voltage cables, graders and scrappers, small face shovels, front end loaders, ditchers, lubrication trucks, fuel trucks, then blast hole drills and lump breakers, all mounted on a crawler or a rubber tires, pump units, fire trucks and ambulance and explosive mining plants and trucks. Then open pit mining terms. Benches are arranged spirally in some open pit mines or arranged as levels with the connecting ramps in others. They range from 8 to 40 meters in width, which is designed for safety and for the equipment that are going to be used in case of open cast mining. The height of the bench faces ranges from 4 to 8 meters in weak rocks and from 15 to 20 meters in moderately strong rocks. In some cases, the pits are with 60 meters faces where the rock is strong. The deposit has to be benched down in a successive interval, and the way in which this is done depends on the topography of the deposits or a ore body. For all the period that the pit is mined, a haul road must be maintained into the pit. At shallow depth, the haul road are straight, but the pit becomes deeper, the haul road has to be spiral or zigzag down. The choice of a spiral or a zigzag down depends on the shape and size of the pit and its slope stability. In small pit, a spiral is the only practicable solution other than a tunnel or a shaft access. In a larger pit, the haul road may be established as a zigzag, as a waste wall, while the pit expands away from it. Usually, the term quarrying is employed for dimension stones and crushed stones. Dimension stones is generally loosened slowly and selectively by some methods other than blasting in order to preserve the strength and shape of the product. Crushed stones quarrying for aggregates and for chemical grade rock is done with a variety of blasting patterns depending upon the jointing pattern, on the need for certain size products and on the proximity to urban grades. Blasting, vibration, dust and need for immediate reclamations are of more critical importance than in most other kinds of mining. Geological engineering is especially involved in a quarry site, then selection, environmental monitoring, and the stone is the most widely used product of this entire mineral industry. Then finally, conclusions. Open pit mines range in dimensions from that of the smallest unplanned dugout to that of world's largest mine at Bingham Canyon, Utah, that is in USA, where an entire mountain has been cut away and replaced by a pit. The pit may be 3.2 kilometers long, 2.4 kilometers wide and 1 kilometer deep. Open pit mining has advantages of lower mining cost, easier supervision, larger mechanical appliances and better working conditions in respect of light and air, and it is more safety. It needs no timber for support, higher output and larger productivity, more efficient and usually more convenient use of explosives, fewer skilled workers and higher work ratios.